Alright, this is Math 8. We are on Chapter 1, Lesson 8, looking at roots, or square roots and cube roots, okay? Our key concepts here today is we're looking at, first of all, a square root. And if we recognize a square root, we know that it is x squared equals y, then x is a square root of y. What we're saying here is that what are the two factors of a number that I can break this apart into? So 25, the two factors of 25 are 5 and 5. So the square root of 25 is simply 5. We do the same thing when we take a look at a cube root. It's the same thing. I'm looking for what number can I multiply by itself 3 times to become the factor. So if I was looking at 8, I could look at 2 times 2 times 2 to become a cubed part of 8. So 2 cubed is 8. So the cube root of 8 becomes just simply the number inside that grouping, 2. Alright, so looking at what's inside that grouping, numbers have to match, we're good to go. Let's take a look at some sample problems here from your homework on page 75. This is from your textbook here. When I first begin here, I should back up real quick. When I started this lesson, one of the things I did initially is I made a little cheat sheet here for myself. I went ahead and this is just notes, so hard to read, I know. And I went there and said, what are the squared values of 2 through 20? And I just used the calculator and said, well, 2 times 2 is 4, 3 times 3 is 9. And I went all the way to 20, and at 20 I'm at 400. So I just kind of want to write those down so as I come up to questions today, I had an idea of where about I would look for these things. I did the same with cubes. So 2 cubed is 8, 3 cubed is 27, all the way down to about 12. And that's as far as you generally have to go. In general, you probably want to make sure you probably have memorized 1 to 12 for the squares. And the cubes, you kind of want to get in your head the first probably 5 or 6 numbers there. The rest, you may just have to look up on your calculator as time goes by. But I'm going to have this sheet in front of me while I'm working through these just as a reference because it'll help me solve different problems. So beginning here at the square root of 16, 16 can be broken into which two factors? 4 and 4 make 16. So because 4 times 4 is 16 and they're the same, and I can group two 4's together because square root is like a squared, alright, I have a group of 2 and they match, so the square root of 16 is simply 4. For 484, again, when I looked at my little notes, I recognized that 20 squared was equal to 400. Okay? So this is 484, so it's going to be greater than 20, but not a ton. It's only going up by 84 more. I'm not still sure what that is. If I use a calculator, I might be able to figure it out. But in the meantime, since I don't have a calculator with me, what do? Well, I'm going to break that apart into some smaller segments. I'm going to divide it by 2. I'm going to put a 2 there, and 484 divided by 2 is 242. I still don't know what 242 squared is, so I'm going to put a 2 there and break it into 121. And 121, I remember from my math facts, is 11 times 11. So at this point, I actually have a grouping of, and ready, follow me here, I have an 11 times 2 here, and I have another group of 11 times 2 there. So I actually have two groups. I have 11, oh, not an H, sorry about that. I actually have an 11 times 2, and I do that 2 times, right? It's squared. So what we're saying here, 11 times 2 is actually 22. So 22 squared gets me to 484. So the square root of 484 is actually going to be 22. But I'm not quite done yet because there's a negative in front of here. So I'm going to pull the negative over and make it a negative 22. So the square root of 284 is 22, and I insert the negative to my solution right there. Now that's different than number 3. Because number 3, if I break apart 36, I could get a 6 and a 6. That looks great, except I need to come up with a negative 36. And if I make that a negative and that a positive, well, they don't match. So it's actually not possible here. There is what we would call no real solution. And we say no real solution because when you get to Math 2, in a few years from now, we will tell you what the solution is using imaginary numbers, but that'll be another time and another lesson. So for now, with this negative underneath this symbol, with a squared value, there's no real solution. That won't be the same when we come down to something like number 11 and we have a negative, because a negative times a positive times a negative, or sorry, a negative times a negative times a negative can still be negative. whereas a negative times a negative cannot be negative. So it'll change to a cube, but that's the rule for our squared for now. Let's take a look at number 5. Number 5, they give us a decimal value. We have 2.56. I'm going to pretend for now that it's just 256, and if I use my little cheat sheet here, I look on my little cheat sheet and I go 256, oh, that is 16 squared. 16 squared is 256. So what I have here is I go, well, I know it's 16, but it's not just going to be 16, it's going to be 1, because I moved over 1 decimal point here, I'm going to go 1.6 will be my solution there. Now, I'm not done though once again, because just like up in number 2, I have a negative in the front, so we're going to say negative 1.6. What could you do if you weren't sure about that? Again, I could break 256 apart into, divide it by 2, for example. So 256 divided by 2, 256 divided by 2, using my quick calculator, I get 2 and 128. 128 divided by 2 gives me 64, so I have a 2 and a 64. And 64 broken apart is 8 and 8. So just like our previous problem, I can see I have an 8 times 2 and another 8 times 2, right? Here's my 8 times 2 and my other 8 times 2. So 8 times 2 is what? Oh, it's 16, and that's how I got to 1.6. So I could work that out the long way, or I could look at my little cheat sheet and know that, 256, square root of that is 16. I want 2 points, so I would do 1 point, and that's my solution there. Let's look down at number 8. We have to solve each equation now. The way we solve each equation is we're going to do the inverse operation here. This is w squared, so what I want to do is I'm going to say, well, I'm going to take the square root of both sides. The square root of w squared means the square root cancels out the square, so on this side I just have w equals the square root of 36 over 100. Now, 36 over 100, these are nice numbers here. So the square root of 36 happens to be 6, because that's 6 times 6. And the square root of 100 happens to be 10, because that's 10 times 10. 6 over 10 can be reduced, divide both sides by 2, and we end up with 3/5. But whenever we take the square root of something like this, it could be a positive or a negative value. So we would say for our answer that it is plus or minus 3/5. Now the reason for that is because if you think about a negative one, negative 3/5 times a negative 3/5 is going to give me, well, let's just put a 6 back in there. Well, let's do negative 6/10, negative 6/10, just for the sake of our problem here. A negative times a negative gives me a positive, so I end up with 36 over 100. So a negative times a negative is a positive, so I can have two negative numbers and it works out just fine. So that's how we get that solution right there. Okay, you have a couple more that to work on. This one here again, look at that number 169 and kind of ask yourself, well, what number squared can get me 169? If 12 times 12 is 144, you know it's got to be bigger than 12. That's just a little hint there. Let's look at number 10. 10, we have the cubed root of 1,728. That's a very large number. I'm not really sure what that's going to be, so I had to play with it a little bit. If I looked at my little notes, I could figure out what that was going to be, but let's pretend I don't have my notes with me and I'm not sure, I don't have a calculator. What do? I'm going to break this apart and do the long way. So here's a 2, and if I divide 1728 in half, I end up with 864. If I divide 864 in half, I have 2 times 4, 32. Divide that in half, I end up with 2 times 2, 16. Divide that in half, and I have 2 times 108. Divide that in half, and I have 2 times 54. Now once I get to 54, now I have something interesting going on, because 54 can go into 6 and 9. 9 becomes a 3 and a 3, and 6 becomes a 2 and a 3. So I have lots of numbers going on here, but if you look at it, I'm going to write them right here on number 2, on number 11. I have 1, 2, 3, 4, 5, 6 2's, 1, 2, 3, 4, 5, 6 2's, and I have 3 3's, just like that. I'm looking for equal groups of 3, meaning the same numbers in groups of 3. Well, what do I have right here? I have 1 3 and 2 2's, I have 1, 3, and 2 2's. And I have 1, 3, and 2 2's. 3 times 2 is 6, times 2 is 12. So what I'm saying is that 12 times 12 times 12 is 1,728. And so the cubed root of 1,728 is actually 12. And again, if I go back to my little cheat sheet, what did I write down here? There's 12, and the cube root is 1728. So sometimes it's helpful to have that. I could have just used that, and off we go, and we're running and going. Number 12 is a little bit easier, the cube root of 27. From my notes, I can notice that 3 times 3 times 3 equals 27. I can also notice that 5 times 5 is 25, times 5 is 125. So that tells me that the cubed root of 27 over 125 is actually 3/5, just like that. Cube root of 27 is 3, cube root of 125 is 5, and I keep it in fraction form for number 12. Let's move on to the back side of this page. Here we have an area that's given. We say the area of this square is 121 square inches. Remember, area is found by taking a side, let's call it x, and multiplying it by itself to find out the area. Or we could write this as x squared equals 121. To find out the value of x, I take the square root of both sides. X then is equal to the square root of 121, which, because it can be plus or doing square root, it could be plus or minus 11, right? It could be. But because I'm talking about a value around the object, I'm not going to have a negative answer. So that tells me that x is going to be 11, because I can't have a negative distance on this square. Question asked, find the perimeter. So I'm not done yet. That's the length of one side is x. One side of x is 11. So there are 4 sides to a square, so I'll multiply by 11, and I end up with 44 inches is the length of the perimeter around the square that has an area of 121. That's a very common problem, so one you just kind of want to keep in mind. Number 18, we have the square root of 36 squared. If you want to do it in steps, you certainly could, but what you might want to recognize here is that essentially the square root and the square are going to cancel each other out. But let's, for the sake of argument, work on it. Ready? So, what is the square root of 36? Well, that breaks apart into 6 and 6. So square root of 36 is actually 6, but we still have the square to deal with, and 6 squared happens to be 36, so we're back to where we started. So essentially, those cancel each other out, and you're left with just the numerical value there. And that's the same for the remaining problems on that page as well. Let's slide over to extra practice because there are a few of these I just want to kind of cover to make sure you're on the right track as you work on these ones. 28, we have plus or minus the square root of 1.44. I recognize that 1.44 looks a lot like 144, and 144 is 12 times 12. But in this case, because we're dealing with 1.44, I recognize that, well, it's not going to be 12 because that's not going to quite work out very well. I'm actually going to do 1.2, 1.2. And so my solution, I have a plus and minus in front, I carry that over, is plus or minus 1.2. So it's a lot like 12, but just has a decimal there. On number 29, again, we have another one with cube roots. Trying to figure out what could that cube root be. You may not recognize that cube root. I can look on my little cheat sheet and tell you what it is right away, but let's pretend that we don't have that. So if I break this apart, this can become 2 times half of 216 is 108. Okay, well, that's still not helping me quite yet. So what's 108 divided by 2? Well, 108 divided by 2 is 2 times 54. 54 becomes 6 times 9. 6 becomes 2 times 3, and 9 becomes 3 times 3. So I factored it down to its least common multiple here, and we get down to our smallest little parts. And I have 2, 2, 2, 3, 3, 3. So if I was to partner these up, I would have a 2 and a 2 and a 2, as well as a 3 and a 3 and a 3. And notice I have 3 groupings of these things, right? And that's what I'm looking for is 3 factoring groupings. So 2 times 3 is 6. So we would say safely that 6 times 6 times 6 is 216. Because I want it to be a negative answer, though, I'm going to say that negative 6 times negative 6 times negative 6 is negative 216. And that would be an accurate statement. So that's how we do number 29. Let's look at a few down here in the bottom as we wrap up this lesson. We have 1/8 equals z cubed. To solve this one here, what I'm going to want to do is I'm going to want to take the cube root of both sides. Right? To get rid of the cube there, I do the cube root of this side and the cube root of that side. And that will make that disappear. And now I have the cube root of 1/8 equal to z. Okay? Now, what is the cube root of 1/8? Well, the cube root of 1 is 1, because 1 times 1 times 1 is 1. And for the 8, I recognize that 2 times 2 times 2 is equal to 8. So I end up with z equals 1/2. Okay, equals z. There. On number 37, kind of a strange one once again, I have this big number, 1.331. All right? Now, if you think about this real quick, I'm doing the cubed root thing. All right? What is 10 times 10 times 10? Well, 10 times 10 times 10 is 1,000. With that in mind, I'm going to take a little guess here and go, I'm only going a little bit more. What would 11 times 11 times 11 be? Well, it happens to be that 11 cubed is actually 1,331. So when I take the cube root of both sides, I can say that it's going to be somewhere around, not 11 because of the decimal, but I'm going to end up with 1.1 as my solution for that problem right there. And finally, our last one here we're going to look at today, number 39. On number 39, we have the square root of x equals 5. To get the x by itself, I will, this time, do the opposite thing. I'm going to, let's make it bigger here, I'm going to square both sides to get the x by itself. Squaring the radical makes the radical go away, so x is now equal to 5 squared, and 5 squared is 25. Alright, so just a few examples there to help you through your homework tonight. Again, I hope that helps. If you have more questions, just check in with your teacher tomorrow. Thanks.